right, so good morning everyone. So welcome to my class. So
Good morning, sir.
yeah,
Good
during
morning, sir.
during our previous discussion, we already defined big data. We also discussed the luminaries or the people who first use and introduce big data, their thoughts, their understanding, and their strategies on how they make use of the data. And of course, the tools that they have used. We also discussed the different milestone of big data where we discuss how it evolves and grow until such time that we call it big data. We also discussed the different properties of big data and the other preliminary concepts of big data. Because of the influx of big data, companies and enterprises were trying to make use of it by continuously developing and improving their systems and infrastructures. And this is the reason of the advancement in technology. And now we will try to learn how to frame big data analysis problems on APACHE Spark scripts. We will also try to develop the distributed coded using Scala programming language or any other programming language used by most analysts, such as Python programming. Python, by the way, is mostly used by data analysts and data scientists and other analysts who are deployed and working in a technology company. We will also try to develop, build, and run scripts on Hadoop clusters, transform structured data using Spark SQL, datasets and data frames, and of course, analyze huge dataset with machine learning on Spark. Okay, so we're now going to discuss some preliminary concepts and topics on Hadoop. Okay, so if you already checked your email, I have sent you your final requirements for this term. So I am asking you to create your own use cases so that when you are, deploy in a company or in a technology company, you will ask how to build and curate a use case for the company to offer to their stakeholders. So this is an example of a use case, no? So no need for you to copy this. So this is just a guide for you to Okay. So the background, an e-commerce site XYZ having 100 million users wants to offer a gift voucher of $100 to its top 10 customers who have spent the most in the previous year. Moreover, they wanted to find the buying trend of these customers so that company can suggest more related to them. All right. So, okay. So, what is the issues involved in natakpan na yung aking presentation ng mukha. Paano ba i-set? Alright. Okay, so what is the issues involved? So huge amount of unstructured data which need to be stored, processed, and analyzed. So the solution is that you should have a storage. This huge amount of data, okay, Hadoop uses the HDFS, or the Hadoop Distributed File System, which uses commodity hardware to form clusters and store data in a distributed fashion. It works on write once, read many times principle. So, meaning to say, you are going to store data at one time or in one time, but then you can read it, or you can extract as many as you can, as many times you wanted to extract. Okay. So the processing here is that you're going to use MapReduce paradigm. It's applied to distributed over network to find the required output. So to analyze, you will going to use the page, the hive can be used to analyze the data. Okay. So of course the infrastructure or the system is Hadoop. Okay. So this is an open source. So there is no any other cost when using this platform. Okay. So, okay. So Hadoop is an open source framework from APACHE's part. Right, so you may now turn off your cam para hindi tayo ma-distract. Alright, so Hadoop is an open source framework from Apache and is used to store, process, and analyze data, which are very huge in volume. So, like I said during our previous discussion, we are already defined what is big data. How huge is huge? So, we defined it using its definition, such as the volume, veracity, and variety. Okay? Hadoop is written in Java and is not OLAP, or the online analytical processing. Okay? So it is used for batch and offline processing. It is being used by Facebook, by Yahoo, by Google, Twitter, LinkedIn, and many more. Okay? So especially like Amazon and other big e-commerce companies. So they're currently using Hadoop. Moreover, it can be scaled up just by adding nodes in the cluster. Okay, so these are the modules of Hadoop. First is the HDFS, or the Hadoop Distributed File System. Google uses its paper GFS, and on the basis of GFS was developed. It states that the files will be broken into blocks and stored in nodes over the distributed architecture. Second is Yarn. Yet another resource negotiator is used for job scheduling and manage the cluster. Third is the MapReduce. Right? So this is the framework which helps Java programs to do the parallel computation on data using key value pair. The map task takes input data and converts it into a data set, which can be computed in key value pair. The output of map task is consumed by reduce task, and then the out of reducer gives the desired result. The fourth one is the Hadoop common. These Java libraries are used to start Hadoop and are used by another Hadoop modules. So these are the four modules of Hadoop. Okay, so we're now going to discuss the Hadoop architecture. So the Hadoop architecture is a package of the file system, MapReduce engine, and the Hadoop distributed file system. The MapReduce engine can be MapReduce 1 or Yarn MR2. A Hadoop cluster consists of a single master and multiple slave nodes. So later on, I'm going to show you the structure of this MapReduce, okay, and the single master or the multiple slave nodes. The master nodes includes job tracker, task tracker, name node, and data node. Whereas the slave node includes data node and task tracker. Okay, so nakakalito lang siya guys, no? So please remember all of these nodes. Okay? And later on, I'm going to discuss each one by one. Okay, so I'm also going to do some actual video on how to use this and how to install Hadoop on your system. Oh, sorry. Okay. All right. So ayan. So is my voice clear?
Yes, sir. Yes, sir.
Yes, sir. It's clear now.
Yes, sir.
Yes, sir.
Okay.
It's better po.
Okay. Sorry. All right. Okay, so this is the structure of the MapReduce layer and the HDFS layer. So there is a master and there is a slave. So the tasks are coming from the master layer, okay? And the tracker of the task are saved and stored in the slave master. Okay, so this is for the MapReduce layer and the HDFS layer. Okay, so the Hadoop distributed file system is a distributed file system for Hadoop. Okay, so it contains a single master or a slave architecture. This architecture consists of a single name node, performs the role of master, and multiple data nodes performs the role of a slave. Both name node and data node are capable enough to run on the commodity machines. The Java language is used to develop the Hadoop distributed file system. Okay, so we're going to use Java language to develop the Hadoop distributed file system. And as you mentioned during our first few lessons, you already have some knowledge about the Java programming. Am I correct?
Yes, sir.
Yes, sir.
All right, so any machine that supports Java language can easily run the name node and data node software. Okay, so this is the name node. Name node is a single master server that exists in the Hadoop distributed file system cluster. So as it is a single node, it may become the reason of a single point failure. It manages the file system namespace by executing an operation like the opening, renaming, and closing the file. It also simplifies the architecture of the system. Okay, so this is just the definition. No? So once we already installed the Hadoop, we can check what this is name node. Okay, so this is the data node. The Hadoop distributed file system cluster contains the multiple data nodes. So each data node contains multiple data blocks. Okay, so these data blocks are used to store data. It is the responsibility of the data node to read and write requests from the file system's clients. It performs block creation, deletion, and replication upon instruction, the name node. Meron bumibitiw sa inyo sa connection, may naglalag. Okay, so this is the data node. The job tracker. The role of the job tracker is to accept the MapReduce jobs from the client and process the data by using name node. Second, in response, name node provides metadata to job tracker. So this is the task tracker. It works as a slave node for job tracker. It receives task and code from job tracker and applies that on the file. This process can also be called as a mapper. So this is the task tracker. Okay, so this is the MapReduce layer. The MapReduce comes into existence when the client application submits the MapReduce job to job tracker. Right. Okay, so in response to the job tracker, the job tracker sends the request to the appropriate task tracker. Sometimes the task tracker fails or time out. In such a case, that part of the job is rescheduled. Okay. Okay, parang magulo yung files ko. Okay, so this is the advantages of the Hadoop. First advantage of Hadoop, this fast. In the Hadoop distributed file system, the data distributed over the cluster and are mapped, which helps in faster retrieval. Even the tools to process the data are often on the same server, thus reducing the processing time. It is able to process terabytes of data in minutes and petabytes of data in hours. So it is scalable. Hadoop cluster can be extended by just adding nodes in the cluster. So cost effective. Hadoop is open source and usually ang dami na naglalag, ang dami mabagal ang internet. Okay, so cost-effective, Hadoop is open source and uses commodity hardware to store data. So it really cost effective as compared to traditional relational database management system. It is also resilient to failure. Hadoop distributed file system has the property with which it can replicate data over the network. So if one node is down or some other network failure happens, then Hadoop takes the other copy of the data and use it. So normally, data are replicated thrice, but the replication factor is configurable. Okay, so remember this. So during failure daw, the Hadoop takes the other copy of the data and use it. Okay, so parang may backup system siya. Okay, so data are replicated in thrice, but the replication factor is configurable. Okay, so meaning to say we can able to configure the replication. So still, we can check the duplicate or the triplicate copy of the data. Okay, so the history of Hadoop. All right. Okay, so the history of Hadoop was started by Doug Cutting and Mike Caffarella in 2002. So bago lang siya, 2002. So its origin was the Google File System paper published by Google. So, okay, so in 2002, okay, Doug Cutting and Mike Caffarella started to work on a project which is the APACHE Notch. It is an open source web crawler software project. So while working on the APACHE Notch, they were dealing with big data. To store that data, they had to spend a lot of cost, which becomes the consequence of that project. So this problem becomes one of the important reasons for the emergence of Hadoop. Okay. So in 2003, Google introduced a file system known as the Google File System. It is a proprietary distributed file system developed to provide efficient access to data. In 2004, okay, so guys, not all the discussion that I am mentioning are already in the PowerPoint, no? So you have time to take down notes for your own benefits then. Okay, so in 2004, Google released a white paper on MapReduce. This technique simplifies the data processing on large cluster. Right, so in 2005, Doug Cutting and Mike Caffarella introduced the new file system known as the Notch Distributed File System or the NDFS. This file system also includes MapReduce. In 2006, Doug Cutting quit Google and joined Yahoo. Okay, so on the basis of the Notch project, Doug Cutting introduced a new project Hadoop with a file system known as the Hadoop Distributed File System. Okay, Hadoop first version is 0.1.0, released in 2006. So, kailan ba nag-umpisa si Google, guys? So, are you aware of the history ni Google and the Yahoo during that time? Okay, so the history of Google and Yahoo is that in 1998, or if I were not mistaken, during that time, Google was just starting, and they offer to buy Yahoo for about 30 billion. No, so they are offering Yahoo to buy for amounting to almost 30 billion, something like that. And then, but Yahoo refused to sell. And 2004, again, Google reached out to Yahoo. So they again offer to buy Yahoo, but then hindi pa rin pumayag si Yahoo. Okay, so hindi pa rin niya binenta kay Google yung company. So after 2004, so as you can see, that is start yung operation ni Google. And until now, sobrang lakas na ni Google. Okay, so this is a very one of the big companies today. And in 2007 or 8, Yahoo decided to sell their company to another company for only 4 million. Okay, so they lost a lot during that time. Okay.
Sir, I'll be back as soon as I can, sir.
Okay, sure. It was already also recorded din naman. You can go listen naman sa
Okay po, sir.
Sky.
Okay, thank you.
Okay. And yun, so it's a big loss kay Yahoo during that time because yung offer sa kanila na billions of money ay naging millions na lang. Okay? So amounting to 4 million na lang. So sayang yung pera na pinakawalan nila. So that's why now, as you can see, hindi mo alam kung nasan na ba si Yahoo. Okay, I'm not actually using Yahoo now. So, but still I have my Yahoo email. But then again, it was not as seamless as it is like Google or the Gmail na ano nila. And also the search engine of Yahoo becomes also top 1 search engine before. And because of the opportunity na nawala sa kanila, yan, nalampasan sila ni Google. Alright, so Do Cutting named his project Hadoop after his son's toy elephant. Okay, so kaya kung mapapansin ninyo yan. Kaya elepante yung kanyang symbol ni Hadoop. Okay? So, Do Cutting named his project Hadoop after his son's toy elephant. In 2007, Yahoo runs 2 clusters of 1,000 machines. In 2008, Hadoop became the fastest system to sort 1 terabyte of data on a 900 node cluster within 209 seconds. So in 2013, Hadoop 2.2 was released. And in 2017, Hadoop 3.0 was released. Okay. So to summarize, okay, so in 2003, Google released the paper Google File System or GFS. In 2004, Google released a white paper on MapReduce. In 2006, Hadoop introduced. Hadoop 01.0 was released. Yahoo deploys 300 machines, and within this year, they reaches 600 machines. Okay, that is in 2006. In 2007, Yahoo runs 2 clusters of 1,000 machines. Hadoop includes HBase. Okay, in 2008, Yarn Jira opened. Okay, in 2008, Yarn Jira opened. Hadoop becomes the fastest system to sort 1 terabyte of data on a 900 node cluster within 209 seconds. Yahoo clusters loaded with 10 terabytes per day. Cloudera was founded as a Hadoop distributor. Okay, so kaya pag nag-research kayo sa internet, lalabas yung Cloudera o tinawag siyang Hadoop Cloudera. Okay, so it was introduced in 2008 as one of the distributor of Hadoop. Okay, si Cloudera. So ibig sabihin, yung Hadoop is running on a Cloudera platform. In 2009, Yahoo ran 17 clusters of 24,000 machines. Hadoop becomes capable enough to sort a petabyte of data. MapReduce then and the Hadoop distributed file system become a separate sub-project. So in 2010, Hadoop added the support for Kerberos. Hadoop operates for 4,000 nodes within 40 petabytes. Apache Hive and Pig release. So in 2011, Apache Zookeeper release. Also, Yahoo has 42,000 Hadoop nodes and hundreds of petabytes of storage. So yun yung some of the historical milestone ni Hadoop. Okay, but okay. So I already discussed the system. Apache consists of sub-projects. So the Hadoop MapReduce and the Hadoop distributed file system. So HDFS takes care of the storage part of Hadoop application. MapReduce applications consume data from HDFS. So HDFS creates multiple replicas of data blocks and distributes them on to compute nodes in cluster. This distribution enables the reliability and the extremely rapid computation. So the MapReduce, on the other hand, is the computational model and software framework for writing applications which are run on Hadoop. These MapReduce programs are capable of processing enormous data in parallel, okay, on large cluster of computation nodes. So they store data on its DFS and then kukunin ni MapReduce yung data from the HDFS. Although Hadoop is the best known for MapReduce and its distributed file system, the term is also used for a family of related projects that fall under the umbrella of the distributed computing and large-scale data processing. Other Hadoop-related projects at Apache includes the Hive, the HBase, the Mahout, Scoop, Flume, and Zookeeper. Okay, so I already discussed the features of Hadoop, the scalability, the fault tolerance, and so on and so forth. Okay, so we're now going to discuss the network topology. Network topology in Hadoop. Topology or arrangement. Okay, topology is the same as arrangement. Okay, so the arrangement of the network affects the performance of the Hadoop cluster when size of the Hadoop cluster grows. Okay, so there are multiple clusters daw in Hadoop. Parang sa isang kumpanya, there are thousands or hundreds of computers. Okay, there are hundreds of computer servers, and as an analyst, for example, you are going to extract data using your machine, and the data that you are getting from your machine are actually connected from the server. Okay, that's how HDFS works. Okay, that's how Hadoop works. So maraming computer sa isang company, but then when you extract data using your machine, yung data na kinukuha mo doon sa using your machine or local machine are coming from these servers, coming from these computers. That's how Hadoop works. Okay, so imagine if you have some sort of small data, di ba? Sinesave mo lang yung data mo sa local machine, and then you can just open it. Okay, but that is an ordinary data. Okay, yung mga maliliit na data lang yan, mga structured data lang yan. And Microsoft Excel, for example, has the maximum of 65,500 rows. Okay, so when your rows exceed 65,500, hindi na niya actually nababasa yung data o hindi na niya nakikita. And even the CSV file, hindi na rin, meron siyang limitation. Okay, so imagine if you have big data on your local machines, kahit na yung memory ng machine mo is say 1 terabyte. Okay, sa 65,500 rows pa lang, hindi mo na mabubuksan yung data mo, okay, sa Excel. So that's the purpose of Hadoop. So meaning to say the main data are stored on Hadoop. Okay, and you're going to extract using your skills in SQL and other extracting tools. Okay, so in addition to the performance, one also needs to care about the high availability and handling of failures. So in order to achieve this, Hadoop cluster formation make use of the network topology. Typically, network bandwidth is an important factor to consider while forming any network. However, as measuring bandwidth could be difficult, in Hadoop, network is represented as a tree, and distance between nodes of this tree, or the number of hops, is considered as important factor in the formation of Hadoop cluster. Here, distance between two nodes is equal to sum of their distance to their closest common ancestors. Hadoop cluster consists of data center. Okay. The rack and the node which actually executes job. Here, the data center consists of racks and consists of nodes. Network bandwidth available to process varies depending upon the location of the processes. That is, bandwidth available becomes lesser as we go away from process of the same node. different nodes on the same rack, nodes on the different racks of the same data center, nodes in different data centers. Okay. Okay, so what is scoop? Okay, so analytical processing using Hadoop requires loading on huge amount of data from diverse sources into Hadoop clusters. This process of bulk data load into Hadoop from heterogeneous sources and then processing it with a certain set of challenges. Maintaining and ensuring data consistency and ensuring efficient utilization of resources are some factors to consider before selecting the right approach for data load. Okay, so that is okay, so these are the major issues in scope. Data load using scripts. Traditional approach of using scripts to load data is not suitable for bulk data load into Hadoop. This approach is inefficient and very time consuming. So this is the major issues in scope. Data load using script. Second, direct access to external data via MapReduce application. Providing direct access to the data residing at external systems without loading into Hadoop. For MapReduce applications complicates this application. So this is not a good approach. Okay, so this is not feasible. Third is the enormous data. In addition to having ability to work with the enormous data, Hadoop can work with data in several different forms. So to load such heterogeneous data into Hadoop, different tools have been developed. Scoop and Flume are two such data loading tools. Okay. Now we're going to discuss what is scoop in Hadoop. Or we call it the APACHE scoop. Okay, this is known to SQL to Hadoop. Okay. So ito naman yung data na using SQL, you will going to input data to Hadoop. Is designed to support the bulk import of data into the HDFS from structured data stores such as relational databases, enterprise data warehouse, and NoSQL system. So yung NoSQL system, ito yung ginagamit natin for unstructured data, no? Kasi big chunk of big data is actually not structured or unstructured. So we're going to use NoSQL. So magkaiba yung SQL, yung SQL sa NoSQL, guys, ha. So yung SQL are mostly used for the structured data and semi-structured data. But if we're going to handle unstructured data, we're going to use the NoSQL. So scoop is based upon a connector which architecture which support plugins to provide connectivity to new external systems. An example of use case of scope is an enterprise that runs a highly scope important to load the day's data from production into the transactional RDBMS or the relational data management system into Hive. Okay, into Hive data warehouse for further analysis. the scoop connectors, all the existing database management system are designed with SQL standard in mind. Okay. However, each DBMS differs. Okay, so however, its DBMS differs with respect to dialect to some extent. So this difference poses challenges when it comes to data transfer across the systems. Scope connectors are components which helps overcome these challenges. Data transfer between scope and external storage system is made possible with the help of Scoop's connector. Scoop has connectors for working with a range of popular relational databases, including MySQL, PostgreSQL, Oracle, SQL Server, and DB2. Each of these connectors known how to interact with the associated DBMS. There is also generic JDBC connecting to any database that support Java JDBC protocol. So in addition, Scoop provides optimized MySQL and PostgreSQL connectors that use database-specific APIs to perform bulk transfer efficiently. So in addition to this, Scoop has various third-party connectors for data stores. So ranging from the enterprise data warehousing, which includes the Netezza, Teradata, and Oracle, to NoSQL stores such as the Couchbase. So however, these connectors do not come with the Scoop bundle. Those need to be downloaded separately and can be added easily to an existing Scoop installation. All right. Okay. So, all right. So these are the Hadoop-related projects. No? So now we're going to discuss the Flume. Okay. So Apache Flume is a system used for moving massive quantities of streaming data into the HDFS, collecting log data present in log files from web servers and aggregating in the HDFS for analysis. So in one common example of a use case of Flume. All right, so Flume supports the multiple sources like tail, which pipes data from the local file and write into the HDFS via Flume, similar to its command tail. Second is the system logs, and 4 is the Apache log4j, which enables Java applications to write events to file in the HDFS via Flumes. Okay, so let's have some 10 minutes break, guys. Medyo sumakit yung aking lalamunan.
Sir,
Yes.
Hindi po, sir.
present po.
Sige, pagbalik natin, mag-attendance ako. Hindi pa ako nag-attendance.
Hi, sir. Thank you po.
Okay, sige. Let's have a break for about 10 minutes. So, inom lang ako ng kape para nilalamunan ko. Thank you, guys.
Yes, sir.
Alright, so the data flow in Flume. Alright, so a Flume agent is a JVM process which has 3 components. Okay, so the first components of a Flume are the following: the Flume source, the Flume channel, and the Flume sink, through which events propagate after they initiated at an external source. So in the diagram, the events generated by external source or web server are consumed by Flume data source. The external source sends events to Flume source in a format that recognized by the target source. Flume source received an event, stores it into one or more channels. The channel acts as a store which keeps the event until it is consumed by the Flume sink. This channel may use local file system in order to store these events. Flume sinks removes the event from a channel and stores it into an external repository, okay, like the HDFS or the Hadoop distributed file system. There could be multiple Flume agents, in which case Flume sinks forwards the event into the Flume source of next Flume agent in the flow. So these are the features of the Flume. Flume has flexible design based upon the streaming data flows. It is fault tolerant and robust with multiple failover and recovery mechanism. Flume has different levels of reliability to offer, which includes the best effort delivery and an end-to-end delivery. Best effort delivery does not tolerate any Flume node failure, whereas the end-to-end delivery mode guarantees delivery even in the event of a multiple node failures. Flume can carry data between the sources and sinks. This gathering of data can either be scheduled saan yung chat? Okay. Okay, so Flume carries data between sources and syncs it. This gathering of data can either be scheduled or event-driven. Flume has its own query processing engine, which makes it easy to transform its new batch of data before it is moved to the intended sink. Okay, possible Flume. Possible Flume sinks include the HDFS and the HBase. Flume can also be used to transport event data, including but not limited to the network traffic data. Data generated by the social media, websites, etc., and email messages. Okay, so this is how it goes, as you can see in the figures. Alright, so let's check the other topic. Okay, so the introduction to Scoop versus Flume versus the HDFS in Hadoop. Okay, so for the Scoop is used for importing data from structured data sources such as RDBMS. Okay, so again, this is the introduction between the Scoop, Flume, and the HDFS in Hadoop. Okay, so let's discuss first the Scoop. Okay, again, Scoop is used for importing data from structured data sources such as the RDBMS. Second, Scope has a connector-based architecture. Connectors know how to connect to the respective data source and fetch the data. Third, HDFS is a destination for data import using Scoop. Scoop data load is not event-driven. Okay, so remember that Scoop data is not an event-driven. And the last one, in order to import data from structured data sources, one has to use Scoop only because its connectors know how to interact with the structured data sources and fetch the data from them. Okay, so those are the Scoop functionalities and the features. Now the Flume. Flume is used for moving bulk streaming data into the HDFS. Flume has an agent-based architecture wherein the code is written, which is called as the agent, which takes care of fetching the data. Data flows to HDFS through 0 or more channels. Flume data load can be driven by event. Okay, so Flume data load can be driven by an event. And in order, okay, so in order to load streaming data such as tweets generated, for example, on Twitter or log files of a web server, Flume should be used. Flume agents are built for fetching streaming data. Okay, so hopefully we will have more time to extract tweets from the Twitter and do some analysis from the tweets. So let's say, for example, we're going to do some sentiment analysis about what the people's opinion, thoughts about the COVID. Because there are some people who says that COVID is not actually true. Some are claiming that it is just a plan to distract something or plan to distract the government or the finance sector, something like that. So we will going to do some sentiment analysis by getting the tweets data. Okay, so Twitter are the most, one of the sources of big data source. Okay, so sana meron pa tayong time to get data from the Twitter. And then HDFS. Okay, so HDFS is a distributed file system used by Hadoop ecosystem to store data. HDFS has distributed architecture where data is distributed across multiple data nodes. HDFS is an ultimate destination for data storage. HDFS just stores data provided to it by whatsoever means. So, okay. HDFS has its own built-in shell commands to store data into it. HDFS cannot import streaming data. Okay? So, using HDFS daw, hindi tayo pwede mag-import ng mga streaming data using HDFS. Okay? So, those are the introduction about the Scoop, Flume, and the HDFS in Hadoop. Okay, another topic I want to discuss. Okay. All right, so maybe let's separate this actual demonstration, or for example, how to create first Flume programs, how to install Hadoop, how to install the pig, and learn how to use Uzi. Okay, let's going to discuss this on our next meeting. Okay, so sino pa sa inyo yung sa hindi nakakapag-recite? Para hindi tayo mabombard ng information. Let's separate yung actual doon sa mga theory, sa mga concepts. Saan yung listahan ko? Sino pa guys sa inyo yung hindi nakakapag-recite? Meron pa ba sa inyo hindi nakakapag-recite? So, as I want to discuss the actual...
Sure.
Yes?
Wala po kami, hindi po kami sure. Wala po kami list.
Teka, saan na ba yung listahan ko? Okay, so yung nag-discuss na before dun sa is Xiaoji, Wayne, John, Ayan, Kilpatrick, Jose Gabriel, Maranya, Mika, Matthew, Tring, Grant, Roniela, Anika, Yule, and Eunice. So, sino pa yung wala sa nabanggit ko? Siguro yun yung kailangan. Okay, so there's only few na lang pala. So, mga 5 na lang yung mga wala. Who else? Sino yung gusto mag-volunteer dun sa wala sa mga nabanggit ko? Okay. Wala na guys. Sinong gusto mag-volunteer? So, we'll try to finish it ngayon sana kung para lahat was able to present their understanding on big data. So, is there anyone guys to volunteer or I just need to call your name?
Sir, presentation po ba or for the Hadoop?
Yung presentation natin before about the big data.
Okay sir, tapos na po.
Oo. So ito yung mga natapos na, no? I will call your name again. So Xiaoji, Wayne Navarra, John Cueto, Ayan Swasba, Kilpatrick, Jose Gabriel, Maranya, Mika, Matthew, Tring, Grant, Roniela, Anika Marie, Yul, and Eunice Faith. So those are already presented their exercises on big data. So the name that I did not mention, the one who have not presented their seat work yet. Wala ba guys? Ano? So because we were not going to handle this or to go back to this portion by next meeting because we will be having I'll announce if we have a midterm on our next week, on next Saturday. Yeah, tama. So hanggang 27 pala yung midterm. So, wala guys. So, okay, then so if there's no volunteer yet, okay, so we will be having a midterm exam by next meeting. And please make sure to listen again to the recording. And remember that not all recordings nakalagay doon yung topics, yung mga pinresent ko because I wanted you to listen doon sa recorded discussion because kapag yung PowerPoint is, if everything is included in the PowerPoint, all you need to do is just to browse it. You need to only check it, what is written, something like that. But if there are some discussions or topics or lessons that are not in the slides, of course, you are forced to listen to the recording in order for you to remember the topics that I have mentioned. Okay, so that's the purpose of having this strategy. So not all the lessons or the topics are included in the PowerPoint slides. So for you to be able to listen to the recording. Okay, guys? Is there any other question before we have a midterm exam by next Saturday?
Sir, question po regarding dun sa use case na final requirement po.
Yes.
2 weeks before the end of term po ba yung deadline?
Yes, 2 weeks before the term because we will need to discuss it.
So parang basic example po sir, 2 use case each sector sa lahat ng sector na binigay niyo po sir?
Yes, correct.
Tama. Okay, yun lang po sir. Thank you.
So yun, the purpose of that is because, for example, you will going to deploy in a technology company, you will be actually asked to build, to drop your own use cases and present it to your client. That's how consulting company works. So for example, Accenture Philippines, Regus, and other technology company. So they are offering their services to their clients. So what they're going to do is to build, curate, and drop use cases and present these use cases to their clients. Okay? And yung makakapag-present ng mga use cases na yun, for example, if the clients is interested to get the services of that consulting firm, of course, kung sino yung nag-drop ng use cases na yun, that will be the one who are going to be deployed in that company. Okay? So, don't use this, don't waste this opportunity kasi I tell you guys, so jobs like business intelligence job, data engineers or data scientists is one of the most high-paying jobs today. So that's what they required. So in fact nga, kung meron kayong time, although it is not part of our syllabus, no, try to learn something about Python programming. Okay, I'm actually offering a Python programming course, but it was in space sa mga graduate students. Alright guys, so is there any other question?
So sir, so since 8 po sir yung sector na binigay niyo, so 16 lahat ng use case na gagawin po. Or parang mali yung understand. Okay. Yun lang.
Yes, mabilis lang naman siya. No need to discuss to drill down yung discussion about that. So just lang siya.
Kahit short lang po.
Oo, i-check lang natin siya if how organized it is, how feasible, something like that.
Okay, yes. Thank you po, sir.
Okay,
Sir,
so
question.
yes.
Sir, lahat ng use case na gagamitin is all original, sir? Or gagamit po kami ng existing use cases?
It depends on you kung original or kung meron kayong makikitang use cases from the internet. Okay, it's up to you kasi the thing is if you're doing it in your own space original parang ganon, of course makikita natin how creative you are. Kumbaga yung dedication mo, your focus mo on big data, on your subject is makikita natin dito sa lesson na to.
Sir, pwede po ba, let's just say there's an existing use case, then we cite that, then but we have our own take on it. Parang i-modify, sir.
Yes, it's okay naman din yun. I don't actually think whether it is your own use case or it is original or not. As long as there is something na meron kayo may present. Kasi para the idea is that for you to be able to know how to create a use cases or how to build a use cases. That's the idea.
Okay, sir. Thank you po.
Sir, yung midterms po next week, is it sa Big Sky po ba?
I'll announce by Friday maybe or Thursday. And titignan ko muna kasi medyo mahirap maggawa ng exam kapag online. Baka pwede kayong mag-chat to each other to ask questions, to ask answer, something like that. So I need to develop some strategies in order for me to gauge the actual learnings that you got from our previous discussion. No? So, ayan, kasi possible na, although hindi ko ito yung sinasabi that, you're going to